Alright, so this integration chapter is all about finding areas. And so, what we want to do first is to deal with known geometric shapes that we can use off of graphs so we can see the basis for all of this and how we can calculate in a non-calculus form here. So, we're going to look at the 5 odd number problems on page 279 related to this topic. Starting number 23. We're given here an integration from 0 to 3 of 4 dx. And what we're going to do is we're going to change that into an equation that'll go onto a Cartesian coordinate system, understanding that the region that's being created is the x-axis, the x equals 0 line, and the x equals 3 line. So we're getting that. And then on your graph, or on your calculator, you go to y equals, and punch in just 4, don't worry about the dx. And you should see a straight line going across at y equals 4. So the region being bounded here, being described, is 0 and 4 for x and the x-axis here, and then the line y equals 4. So the green stripes here represents the region that is bound by all those lines. And as you can see, that's a rectangle. And if you can look at this, you can see that this is 4 right here, and this is 3 right here. And since area is length times width, that's 4 times 3, so we get 12. And the fact that we have an integration here, we can actually do it another way, using integration and using the summations that coincide with it, we'll come up with that answer. But what we're going to do instead is just deal with known geometric features. So the first one here is a rectangle that's been created by the areas bound. Problem number 25, this is the equation now. The integration from 0 to 4 of x dx, that then can be rewritten as a function where f of x equals x, which means y equals x. Well, this is a straight line with a slope of 1 and going through the y-intercept is 0. And so, and this is bound by the x-axis, x equals 0, x equals 4. So this is what I have right here. Now y equals x, like I said, is a 45-degree angle, oblique line, and it starts down here and this at 0, 0 and hits up here at 4, 4, because x and y are equal. So now we have a triangle, and the triangle area is 1/2 base times height. Well, the base is 4, the height is 4, so 1/2, 4 times 4 is 8. And so this integration right here will have an answer of 8. Okay? Problem number 27, this is the integration we're dealing with. Now we're dealing with a line that isn't quite as easy to figure out, but we know some information about this. Excuse me. We write this as the function y equals 2x plus 5. Well, b is 5, that's the y-intercept. M is 2, that's the slope. So we have this right here. The line is cutting across here with y equals 2x plus 5. And it hits the y-axis at 5, that's our b of y equals mx plus b. And then if you plug in 2 for x, 2 times 2 is 4, plus 5 is 9, so it's going to go through the point 2, 9. So these are the 2 points right here. We draw a cute little green stripes there. This is bound by x-axis, x equals 0, x equals 2, and we get this lovely shape right here. This is a trapezoid, although most of the trapezoids that you probably dealt with in middle school and maybe some high school was they were kind of like tilted this way. This is kind of 90 degrees away from what most people consider as a trapezoid. But the definition of a trapezoid is any quadrilateral which exactly one pair of sides is indeed parallel to. So this is going to be then the formula for trapezoid. This is always bugging me about how some teachers teach as well as the sum of b1 plus b2 in parentheses divided by 2 times the object. Just say it in a way that people can understand it. everything for rectangles and parallelograms is base times height, right? Well, this is base times height too, except that the base is an average base. But it's still base times height. So what are the bases? Well, we have here a base here. We have two bases. I call this base 1, which is 5. And parallel to that, the two bases must be parallel to each other. The second base, or base 2, is 9, going from here to here. So the average base would be the sum of 9 plus 5 over 2, which of course is 7, times the height. And the height is the difference between the two bases. How far apart are they? And as you can see, that is 2. So we multiply by 2. 7 times 2 is 14. And so our area is in E14. Number 29 has an absolute value. Now, when you punch that into your calculator, which if you do have an absolute value problem, there's an ABS key that you can hit. If you go to variables and hit ABS, you just hit 1 minus ABS-X. Okay? So, if you and then you hit graph, and I would suggest, since you're going no higher than 1s on all these things, I would go to your windows. You go from -2 to +2 for X and Y both. And so you get a much better look at what the graph looks like. But it turns out looking like an isosceles triangle. And since this is just like a regular triangle, which is again 1/2 base times height, we have to identify the base, which is the 2 right here, and the height here, which is 1. And 1/2 base times height is 1/2 2 times 1, which is just plain 1. So the area of that is 1 whatever, 1 unit, whatever, or square unit, I guess. All right, the last one is number 31. Now, for this one, if you were to plot this, y equals the square root of 9 minus x, you'll only get half of this. You won't get the full thing. There's a couple of reasons why I put the full thing on there. Because I wanted to demonstrate the fact that you can get a full circle on there if you use y1 equals this, and then y2 equals negative this. So if you want a circle, it'll come. The problem is, on your graph, that your x's and y's are not equally spaced to each other. In other words, the distance between all the x's, the x dots, and the distance between the y dots are not the same. They are the same for all x's, they are the same for all y's, but they're not the same for x's and y's. So, regardless, you'll get something that looks like an ellipse. But regardless, this is what you should get here. This top part is what you should get for your graph. It's going to be more elongated, is what I'm saying. Regardless, this is a semicircle, not a circle. We know the area of a circle is pi r squared. Therefore, the area of a semicircle, the prefix semi means half, is pi r squared over 2. And the radius is 3. So pi times 3 squared over 2 is the area equals 9 pi over 2. And there's your area. So, the problems are going to be pretty much like that, not too complicated. So, your practice problems, as a result, page 279, 24 through 32. Have fun.